Hello everyone, welcome back to our data structures and algorithm series. So the question which we'll be solving today is sorting an array. So we'll be given an array and we have to sort them. Now this question is very simple. If you want to use any algorithm like bubble sort or insertion sort, but as we all know, the bubble sort and insertion sort, all those algorithm takes big of n square. But here it's strictly written that we have to solve it in big of n log n. Right. So the best thing to sort this array in big of and log n is to just use the inbuilt C++ STL function, which is sort, which directly sorts us in big of and log n. But here it's clearly written we can't use any inbuilt function, right? So the algorithm which inbuilt function uses merge sort, the inbuilt sorting function. It also uses some algorithm. So which algorithm is it uses merge sort. So that's why its time complexity is n log n. But we can't use it directly. We have to um, write that entire code of merge sort by ourselves, right? So how merge sort works, we'll see in this video, right? So we have been, let's take the second example. It's a bit bigger than the first one. So let's take this example, right? So I have an array 511200 and I have to apply merge sort here to sort the array, right? So what merge sort does, uh, merge sort is kind of a two-pointer algorithm. So here, let's say initially my I is here and my J is here, right? So what we do in merge sort, we divide the array in two parts, right? So first divide the array. The first part will be 511, second part will be 200, and all this will be done by recursion. So in first part, this is my I and this is my J, right? So now recursion will first complete this subtree, then this will go in here, right? So now I have 511 and 511 is my array. Again it will divide it into, which will be 5 and 1, and here it will be 1. You can take 5 and 1 1 here, it doesn't matter because you have three elements, one of them will have more elements, right? Now again my I will be here and J will be here, right? Now again this will divide into two elements, 5 and 1, right? Now once this is single element, now I know that it can't be further subdivided into two subarrays, right? So what I'll do, now my merge sorts, this call is actually over. So while coming back, I'll just merge these two arrays into a sorted one. Now this in itself is a sorted and this in itself is a sorted. So while going back, I will merge these two sorted arrays, right? So I have 5 and I have 1. While these are in itself, these are arrays are sorted. So while coming back, I'll just do 1 and 5. So this will be, while going back, this will become 1 and 5, right? Now 1 and 5 is sorted and 1 in itself is sorted. So while going back, I have two sorted arrays and I have to just merge them. So I'll merge these two sorted arrays. This will become 115, right? So now I have one sorted array. Now here also same thing will happen. It will be 20 and it will be 0. Now 0 itself in itself is sorted, so no need. Now this 2 will divided by in two different elements, which is 2 and 0. Now 2 in itself is sorted, 0 in itself is sorted. So while going back, I will merge these two sorted arrays, which will become 0, 2. Now I have 0, 2 and 0 here. So these are two sorted arrays. So while going back, I'll just merge this into merge these two sorted arrays, which will become 0, 0, 2, right? So this is 0, 0, 2 and this is 115. Now these both arrays are sorted in itself. So while going back from this recursion call, what I'll do, I'll just merge these two sorted arrays, which will then become 0, 0, 1, 1, 2 and 5, right? So this is how we actually do a merge sort. But the main part is how will we merge two sorted arrays, because while going back from here, we have to merge these two sorted arrays. So let's take an example of how will we solve this. So let's take an example like 2, 2, 0, 5 and 7. This is one array which is sorted in itself, and the second array will be, let's say, 1, 2, 3. So these are two sorted arrays, which is let's say this is array 1, this is array 2. So these are two sorted arrays. We have to merge them, right? So what first we'll do, first we'll make a temporary vector to like store this sorted arrays. So let's say my I will be here and my J will be here. So first I'll compare these two, which of them is smaller, 0. So first I'll put 0 here and I'll move my I, right? So my I is here. Now again I will compare. This is nothing but 1, right? It was 1. So my J is here. And now again I'll compare 0 and 1, which is smaller, 0. So I'll put my 0 here. right? So again my I will move. Now which of them is smaller, 0 or 1 or 2? 1 is smaller, so I'll put my 1 here, and J will move this time. Now again, which is smaller? Anyone, we can take anyone. So let's take this above 2 and let's move here. Now which is smaller, 2 or 5? So 2, so we can put your 2 here and J is here. Now which is smaller, 3? So we'll put our 3 here, and now J will go out of bound. Once J goes out of bound, I will take all the elements from here and I'll just directly put copy paste here. So this is my new sorted array, and this is what I will return. So this is how we do the merge sort. So the basic idea is we keep on dividing the array in two parts. Like I have an array, I keep on dividing into half and half until there is one single element, right? Because single element will be sorted in itself. Once I have that, I'll just, while going back, I'll just merge them into sorted arrays, right? So that's how I do a merge sort. So let's look at the code of the merge sort. So initially, as I said, my I will be pointing at 0, like in this case. My I will be pointing initially at this. Let's change the color. So this is my I, and where this is my J. So initially my I is at 0 and J is at the last index, right? And then I have called the merge sort function, right? Now let's come to merge sort. Now what merge sort does, if my I becomes greater than J, like in this case, I kept on dividing. So in this case, when single element will be there, my I will be here and J will also be here, right? So in that case, my I is equal or greater. So which means if my I passes, or if my I and J are pointing at the same, which means now I don't have to do anything. So in that case, I will just simply return. Otherwise, what I'll do, I'll just find the mid, which is I plus J by 2. Like in this case, I have to divide this array. Let's write it again, which is 5, 511 2005, 511 200 and 5. My I is here and J is here. So what I'm doing, I plus J by 2. That's how I will get middle, right? So my middle index is I plus J by 2. Now I'm calling merge sort again for this middle index. That's what I did, right? My middle is here, right? So in this case, sorry, middle will be it's 2, what's it, it's 200, it's not 5, right? So my J is here, so my mid will be pointing here. So I'm calling merge sort for I to mid and mid plus 1 to J, right? That's what I'm doing here, from I to mid and mid plus 1 to J. But first this call will run. So merge sort will go in recursion, like it will keep on going until there is a single element, and once there is a single element, it will return. Then it will go for the right side, then from mid plus 1 to J, right? Like in this case, from here to J. Once this is over, like once both the calls are over, I have two sorted arrays. Now what I have to do, I have to just merge those two sorted arrays. Like fine, like merge sort for left part, merge sort for right part. And while coming back, I'm just, I have while coming back, I have two sorted arrays and I have to just merge those two sorted arrays. So this is merge. So what this will do, this will merge the two sorted arrays. Now let's look at the merge function. So as I said, int left equal to I and right equal to mid plus 1, because it's I and this is like mid plus 1, right? So what I did, I made a temporary vector. So first, while my left less than equal to mid and right less than equal to J, because like I have two sorted arrays, fine, and my I is here and my J is here. What I'm doing, I'm just comparing these two. I'm just saying I less than equal to, like this is inside the module, this is inside the module. That's what I have checked here. Like both should be inside the module. If any one of them goes outside the module, then I will not continue this loop. So I'm just checking if whichever is greater, whichever is smaller, push that. Like in this case, right is smaller, and push right. Otherwise, push the left. Whichever is smaller, push it in your temporary, and just move. Once this is over, now it is also possible that like I had two arrays. If the size was different, not size, like for example, in this case, where it is, okay, okay, leave it. So like it may be possible that some elements of some array may be there. So that's what I have done here. If my left doesn't go out of the boundary, which means my right went out of the boundary, but my left is still there, so I'll just push all the left elements. Otherwise, my right hasn't went out of the boundary, so in that case, I have just pushed my right. Once this is over, now since I did all these things in a temporary array. What I did, I just copied all this temporary vector elements into my nums like initial vector, because I have to sort it in place. I don't have to create extra vector, right? So I've just replaced all those elements in my initial vector. So that was the merge function. This is a function to nothing but merge two sorted arrays, which is merge two sorted arrays, right? This is nothing but merge sort. So this is how we do a merge sort, and merge sort is a very popular algorithm to sort an array. And even if you use any inbuilt C++ STL function, it also uses the merge sort. That's why its time complexity is n log n. That's all about the merge sort. If you like the video, please do subscribe to our channel, and I'll meet you in the next video. Thank you.